Okay, welcome to lesson 5.5, solving rational inequalities. In this lesson, typically I teach how to solve the inequalities algebraically and graphically. But I am going to skip the graphing method for this year, 2020, 2021. I'm just going to, like a quick overview. If you were graphing, it only works really if you've got 0 on one side of the inequality. Otherwise, the points are too hard to see. So remember what all the weird, crazy graphs look like from 5.3. There's just too many combinations, and if I were to ask you to like figure out where is the graph greater than, let's say this was like -7, it's really hard to figure out where those points are clearly across from the y value of -7. So because this method doesn't work very often, we're going to skip over it and just take a look at the algebraic method. Now the algebraic method involves making an interval chart, which we talked briefly about when we talked about solving polynomial inequalities. We're going to use this method because it works for all of them. This is a little bit different than solving the polynomial ones though, because rational inequalities also involve restrictions. And here again, we're looking at a more complicated situation where I've got like one rational graph and I want to know when is it here, in this case below this rational graph. So if I plotted these two graphs on Desmos, I'd be looking for where is this one underneath this one, which is complicated again to find those intersection points where they flip. So that's why we're going to focus instead on an interval chart. So my first step for this is to figure out the restrictions on x. And I do mean for both sides of the inequality. So for restrictions, same thing as last lesson. I'm just looking for all of the denominators. So for my restrictions, it's where is the denominator equal to 0. We know that the denominator can't equal 0 to come for these functions to be true. So x cannot equal, and these ones are nice and simple, so I'm just going to grab them right from the equation. X cannot be -6, and x cannot be -3. All right, so now that I have that, I'm going to be working on my second step, finding the solutions of the related equation. So we're going to solve this guy, just ignoring the less than or equal to sign for now. And so I'm going to go back to my same strategies that I had in lesson 5.4. This one is a fraction equals a fraction, so I can cross multiply to solve these. And then I'm just going to expand these out. Here, when I expand, I'm going to get x plus 6, that's 6x, and then I'm going to get 1 times x, that's 1x. So I'm going to have 6x plus 1x, that's 7x, and then 1 times 6 is 6. All right, and now that I have it all expanded, I'm going to collect all the terms on one side and make it equal to 0. So I'm just choosing to make my x squared term positive. That's why I'm moving to this side here. I solve 6x minus 7x, it's -x, and then minus the 6. So to solve this, I'm going to try and factor it if I can, and if not, I'll use the quadratic formula. So I'm looking for two numbers that multiply to -6 and add up to -1. I find those two numbers are -3 and +2, and because this is a simple trinomial, there's a 1 in front of the x squared, I don't need to use decomposition. I just plop those numbers right into the brackets with the x's. So this tells me that x is equal to either -2 or +3. Those are my two answers. So now I have four numbers to use in my interval chart. I've got my two restrictions and my two solutions, and I'm going to use them to come up with the intervals. Because if these graphs were to cross each other, it would happen at these two numbers here, right, where they're equal to each other. Or other funny things can happen when you cross over those two vertical asymptotes, and the graphs might flip between one being above or below. So that's why we care about all of those. So we're going to use those both to create the intervals, and then we'll use some test points in each section. So I'm going to set up a huge chart. And across the top of my chart, I'm going to write out all my intervals. When I do this, my intervals are always going to start at negative infinity, and they're always going to end at positive infinity. And then I'm just listing out the numbers to start and end each interval. I'm going to go in order from smallest to biggest. So -6 is going to be my smallest. It ends this interval and starts the next. Then I find the next biggest is -3. It ends this interval and starts the next. And then the next one is -2. The next one is +3. And then 3 and infinity will be my last one. Oops. That's a crazy looking infinity. And so I made my chart bigger than I needed to. Okay, so this works better on lined paper. What I'm going to do for each interval is I'm going to pick a test point. And what that means is I just have to pick some number between negative infinity and -6. You can pick any number you want in that interval. And then what I'm going to do is actually figure out, well, what does the left side equal? So I'm just going to remind myself up here, I had the left side and I wanted it to be less than or equal to the right side. So my left side equation is x + 1 over x + 3. And then my right side equation on the other side was 2x over x + 6. Okay, now what I need to check after I have those two answers is which one is bigger than the other. Remember, what I want is the left side to be less than or equal to the right side. So I'm going to just check that out. Is the left side less than or equal to the right side? All right, let's see what we fill in here. So for my first interval, I'm going to pick some number between negative infinity and -6. I'm going to pick -10. But like, you could pick -100, you could pick -6.5, whatever you want. You cannot pick -6. We already know that -6 is a vertical asymptote on the 1, so this is going to come out to undefined, so that's not helpful. Don't pick -6. So I'm going to plug -10 into my equation, so I get -9 over -7, and that comes out. I am going to use decimals here because I really want to know which one is bigger than the other, so that's got about 1.3. And then this guy here, when I plug in -10, I get -20, and I get -4, and that's exactly equal to 5. So I'm checking now, is the left side less than or equal to the right side? Well, yeah, the left side, 1.3, is less than 5. So yes, this is one of my intervals that I'm going to use in my answer. Moving into the next interval, some number between -6 and -3. Again, you can't use -6 and you can't use -3. They're both vertical asymptotes, they won't be helpful. So we're picking like probably -5 or -4. I'm going to use -4. And then I'm just plugging -4 into my equation here. So I get -3 over -1, and so that equals 3. And then I plug in and I get -8 over 2, and that equals -4. And then I'm thinking about, well, is the left side number, is it smaller than the right side number? Is 3 smaller than -4? No, it's not. So that is not one of my answers, that interval. Now I'm going to pick some number between -3 and -2. Again, I can't pick those two numbers. It's got to be somewhere in between. So you're probably going to pick -2.5, but you could pick -2.4, whatever you like. I'm going to plug -2.5 into the left side equation. You might do that on your calculator. You could do that, step it out in steps if you want. You should get the answer -3. And then I'm going to plug -2.5 into my right side equation. And when I do that, I get about 1.43, and that's -1.43. And again, I'm asking, is the left side number, -3, smaller than -1.43? Yes, it is. So this again is one of my answers. Now I'm picking a number between -2 and 3. 0 is always your friend if you can choose it. When you plug 0 in here, you just get to ignore the x's, and your answer is 1/3, or 0.33. And then here again, you plug 0 in for these guys, well, you just get 0 over 6, which is 0. And then you're asking yourself, is your left side number 1/3 smaller than 0? No, it is not. And then picking any number bigger than 3, I'm going to pick 5, but again, you can pick 1,000. It does something bigger than 3. You're going to plug it into the left side here. I get 0.75, and then I'm going to plug it into the right side. So I'm plugging 5 in for my x's, and I get about 0.909. And then I'm asking myself, is the left side number smaller than the right side number? And yes, it is. So I've got my solutions here, my 3 intervals that work. Now, what I need to be aware of is the fact that I was looking for less than or equal to. So whenever I see less than or equal to or greater than or equal to, sorry, I have greater than or equal to first here and then less than or equal to, you need to use square brackets on your solutions. But you can't use square brackets on restrictions, right? That doesn't make any sense. You can't include a restriction. So making sure that you only change the brackets on the solutions. So remember, this guy is a solution, so he needs a square bracket. And this guy is a solution, so he needs a square bracket, right? I'm looking at these 2 numbers here. I will not put a square bracket on -3 because that was a restriction, and same with -6. So I'll come out with my answer then. Therefore, x belongs to the intervals -6. And I'm going in order from smallest to biggest. And of course, I'm leaving the round bracket on the infinities as well. And I'm all done that question. And that is our only example. I did cut the word problem as well from today's lesson. Enjoy the homework.